Hi, welcome to Bridge course level 2. This is for 6th and 7th class mathematics. Today our topic is multiples and LCM learning outcomes. By the end of this lesson, students are able to learn and find the multiples of any natural number, find the common multiples of given numbers, and they can calculate the multiples of given numbers and obtain LCM from those multiples. They can calculate LCM in different methods like prime factorization method and division method. We can use these multiples and LCM concept in our daily life situation. Look at this picture. What are these? These are bells in a temple. Now look at this picture. What is this? Have you seen this one anywhere? This is electric bell. Automatically it rings. These bells ring automatically by setting equal intervals. Here the first bell rings at every 2 hours and the second bell rings at every 3 hours equally, and the third bell rings at every 5 hours. This type of arrangement has given to these bells. So first bell rings at every 2 hours interval, second bell rings at every 3 hours interval, and the third bell rings at every 5 hours interval. First bell rings at 2 o'clock, then at what time it rings again? First bell rang at 2 o'clock. At what time it rings again? It ring at 2 o'clock, equal intervals of 2 hours each. Hence, it rings again at 4 o'clock, rings again at 6 o'clock, rings again at 8 o'clock and 10 o'clock and so on. For every 2 hours gap, it rings. Look at these numbers. We can write these numbers 2, 4, 6, 8, 10, 12, 14 like this. We can write these numbers as product of 2 with natural numbers like this. 2 into 1, 2 into 2, 2 into 3, 2 into 4, 2 into 5. So these numbers we get here by multiplying 2 with all these natural numbers. Can you write now continuously the next coming numbers? These are called multiples of 2. We obtain these numbers by multiplying 2 with natural numbers. Let us look into these multiples now. Okay children, have you noted in your notebook? Yeah. Now note it down. Do we get multiples for any number? Yeah. Multiples of a number. Here 2 is multiplied with natural numbers. We got multiples of 2 like this. In the same manner, let us write multiples of next number. Now see this second bell. This is second bell. The second bell rings at every 3 hours interval. So it is ringing at 3 o'clock. Then at what time it rings again? Continuously 3 o'clock, 6 o'clock, again it rings at 9 o'clock. Like that for every 3 hours the bell rings, because it is the setting of 3 hours interval each. So it rings at every 3 hours interval. So now write the numbers only instead of writing the clock. These can be written as the product of like this: 3 into 1, 3 into 2, 3 into 3, 3 into 4 and so on. Write in your notebook. Can you write the continuous numbers as we have written like multiples of 2? Now you write the continuous numbers. These numbers are multiples of 3. Dear children, write all these multiples in your notebook. You know multiples and you know the multiplication tables. You might have seen all these numbers in the multiplication table of 3. Let us discuss about the common multiples of 2 and 3. Let us write the multiples of 2 here first. All these are multiples of 2. Write so many multiples of 2, at least 20 multiples, 30 multiples. These are multiples of 2. And now write the multiples of 3. See, can you find any common numbers among these two set of numbers, the common numbers 6 here, again 6 is existing here, 12 here, 12 is existing here, 18 here, 18 is existing here, 24 here, 24 is existing here. Like that I rounded here all common multiples from those two. These are existing in multiples of 2 and multiples of 3. These are common multiples of 2 and 3. Now you can write continuously these common multiples. Among all those, can you write the next common multiple? How much we should add to this 36? First one is 6, second one is 12. Like that you write common multiples of 2 and 3. First two bells ring simultaneously at these hours. So it started at 2 hours, 4 hours, 6 hours, and it started at 3 hours and continually 6 hours, 9 hours, 12 hours. At 6 hours these two bells ring simultaneously. We have seen first 3 bells. Now let us come to this third bell. This is third bell and rings at every 5 hours interval. So if it rings at 5 o'clock, at what time it rings again? Let us write the timings here. 5 o'clock, 10 o'clock, then again you add 5 to each number to get the next number. So like this we can get multiples of 5. These numbers can be written 5 into 1, 5 into 2, 5 into 3, 5 into 4 and so on. How many numbers you can write? Can you write any last multiple here? No. We can write infinite number of multiples for any natural number. So these are the multiples of 5 here. Now let us look the combination of multiples of 2 and 5 now. These are the multiples of 2 here. These are the multiples of 5 here. Children, write these multiples in your notebook. Before I show here, you try to round the common multiples of 2 and 5. Can you find any common multiples here? See the numbers and try to find the common multiples here. Now I am showing on the screen. Look at these numbers. The 10 is existing here and 10, like that next 20, like that next 30, like that next 40 here, like that next 50. Next one is common multiple is 60 and next common multiple is 70. Like that common multiples of 2 and 5 are 10, 20, 30, 40. We can write so many multiples like this. These are the timings of first bell, third bell. So first and third bells ring simultaneously at these hours. 10 hours, 20 hours. For equal intervals of 10 hours, these two bells ring simultaneously. Look this. What are the common multiples of 3 and 5? Write all the multiples of 3 and 5 and find the common multiples of both 3 and 5. Let us come to next topic, that is representation of common multiples of any two numbers pictorially. Let us take two circles here shaded with different colors. First circle is representing multiples of 2 here and the second circle representing multiples of 3 here. Just before we have written all the multiples. Let us copy all the multiples of 2 here. These are the multiples of 2 and these are multiples of 3. Here the blue color shaded one are only multiples of 2 and the middle part common multiples of 2 and 3 and the green one, this part represents only multiples of 3 other than multiples of 2. So here among these 3, the middle part represents common multiples of 2 and 3. See the multiples 2, 4 and 6 here and then 8, 10 and 12 here and 14, 16 and 18 here. And look at these numbers 3, 6, 9, 12, 15, 18 like this. Among all these multiples, the middle part represents common multiples of both 2 and 3. Among all these 6, 12, 18, 24, 30, these are increasing. What is the smallest common multiple among all these? From above, common multiples What is the least common multiple? Have you found it? For this question, write the answer in your notebook. So, I am showing you here common multiples are 6, 12, 18, 24, 30, 36 and so on. What is the smallest one here? The smallest common multiple is 6 here. Smallest common multiple is also say as least common multiple. Shortly, we write LCM. If you write common multiples of any two numbers, we can find the least one. Let us write such common multiples of different numbers. We write the multiples of 4 and 6 and find their LCM. We have found multiples of any number by multiplying the number with all natural numbers. Multiples of 4 are like this: 4 into 1, 4 into 2, 4 into 3. Like this we can write multiples. Any number of multiples we can write here. Hence the multiples are here: 4 into 1, 4, 4 into 2, 8, 4 into 3, 12. Or we can add 4 to the previous number to get the next number. These are the multiples of 4. Write in your notebook. Before I show on the screen, you try to write the multiples of 6. Have you written? Have a look here. 6 into 1, 6 into 2, 6 into 3, like that. The products are 6 into 1, 6, 6 into 2, 12, 6 into 3, 18, 6 into 4, 24. Have you written now? Now here, among all these multiples, try to look any common numbers are appearing here. I am showing you on screen here, squared, red colored squared here, the numbers are common multiples. 12 is appearing at both places, 24 is existing in both multiples, 36 and so on. Write the common multiples: 12, 24, 36. What is the smallest one here? Can you write the LCM of these two numbers now? LCM of 4 and 6 is equal to 12 here, the least one. Let us have another example to write the common multiples and note the observations. Write the common multiples of 5 and 10. 5, 10, 15, and can you write the multiples of 10 here? Yeah, 10 into 1, 10 into 2, like that. Write in your notebook all the multiples of 10. 10 into 1, 10, 10 into 2, 20, 10 into 3, 30, like this. Now try to find common multiples here. Try to find common multiples. All these are common multiples. Now observe, any observation have you found here? These are the multiples of 5 and these are the multiples of 10. Common multiples are 10, 20, 30, 40, 50. All these are common multiples of both. Common multiples we need to write here and then write the LCM. What is the LCM here? What is least common multiple here? Yeah, least common multiple is 10. Let us look another example here. 4 and 8. Write the multiples of 4 and 8. Multiples of 4 already we have written. Those are 4, 4 into 2, 8, 4 into 3, 12, 4 into 4, 16, 4 into 5, 20 and so on. Now write the multiples of 8 here. Among these multiples, can you find the common multiples? Every multiple of 8 is common multiple of 4 and 8 here. All these are common multiples of 4 and 8. Hence the least common multiple is 8 here. From these two observations, let us have a conclusion. Least common multiple of 5 and 10 is equal to 10 and least common multiple of 4 and 8 is 8 here. So what did you observe from these two statements? Hence, if one number is multiple of other, then bigger number is their LCM. Here 10 is multiple of 5, hence 10 is the LCM of 5 and 10. 8 is multiple of 4, hence LCM of 4 and 8 is 8 here. Without writing all the multiples of two numbers. If one number is multiple of other, we can write LCM is bigger number. Now try to answer for these questions. What is the LCM of 7 and 14? Write in your notebook. LCM of 7 and 14 is 14 obviously, and write the LCM of 27 and 9. LCM is obviously, yes, you are right, 27. Now without writing all the multiples, we can write the LCM of 15 and 30 as well. The LCM is 30 here. In this way we can write the LCM for any two numbers without writing their multiples. Now let us come to the next topic, that is prime factorization method to find LCM. Before going to find this method, let us understand the word prime numbers. So prime numbers means a number which has only two factors, 1 and itself, is called a prime number. List prime numbers. Here these are the prime numbers from 1 to 100 here. So many numbers, 2, 3, 5, 7, 11, 13 and continuously. These numbers are called prime numbers. Let us write the numbers in the product of prime numbers, that is prime factorization. Finding LCM of 8 and 12 here in prime factorization method. Okay, for this we have to write 8 first. We have to divide this 8 by prime numbers. As it is even number, we can divide this 8 by first prime number 2. Let us take 2 here like this. Now we are dividing this 8 by 2. We get the answer 4. So write the answer 4 here. Now try to divide this 4 again by prime number. Up to we get the prime number, we need to do this process continuously. Now as it is even number, take first prime number and divide this 4 by this 2. Now we get the answer 2 here. Again we have to divide this 2 by prime number 2 and hence we get the answer is 1. Hence our division of this number with prime numbers is finished. Now 8 can be written as like this. 8 can be written as 2 into 2 into 2. So these 3 should be multiplied to get this composite number. Now let us take another number 12. So same manner we need to divide this 12 by prime numbers. As it is even number, let us divide this by 2. How many times of 2 is 12? 2 into 6 is 12. Again 6 should be divided by prime number. As it is even number, we need to take 2 into 3. So in this manner we need to divide any number, composite number, by prime numbers. Now write the product of prime numbers, these 3, to get the 12. So 12 is equal to 2 into 2 into 3. Now observe these 2. Here 3 times 2 we are observing. Here 2 times 2 and 1 time 3 here. Now we need to write LCM. To write LCM, we take the common multiple prime number from these 2. Hence here it is appearing once. This one should be once, we should write the 2 here, and again instead of 2 times 2 here, we should write 1 time in the part of LCM, and the remaining numbers we should multiply here. So this 2 again and again this 3. So this is the LCM of these two numbers in prime factorization method. So 2 into 2 4, 4 into 2 8, 8 into 3 24. The LCM of these 8 and 12 is 24. So students, try to write prime factorization in this manner and find the common prime numbers and write those here, and remaining leftover numbers we should write here. Okay. So let us look into another example to find the LCM of any two numbers in prime factorization method. Find the LCM of 15 and 18 in prime factorization method. Take 15 here. It is not even number, so we cannot divide this 15 by first prime number 2. Then we should take the next prime number 3. Now 3 divides the 15 here. So 3 into 5 is 15 and 5 is prime number. Hence we need to write 5 into 1 is 5. Now prime factorization of 15 is 3 into 5. Product of prime numbers. This composite number is written in the form of product of primes as 3 into 5. What is the next number in our question? 18. Now write 18 in your notebook. Now try to divide this 18 by prime numbers. Now take 2 here. 2 how many times is 18 here? 9 times. Now as it is not even number, let us go to next prime number is 3. Now 3 into 3 is equal to 9. Hence our prime factorization is finished. Copy these numbers here. 18 should be written as the product of these 3 prime numbers. What are the 3 prime numbers we got here? Yeah, 2 into 3 into 3. Now try to find common prime numbers among these two. Common prime numbers among these all. 3 is the common prime number. So write the 3 here. So write these 3 numbers 5 and next to this number 2 and next to this number 3. Hence the product is like this: 5 into 2 10, 10 into 9. Hence the LCM is 90 here. Okay students, you try to write any two numbers prime factorization by dividing with all prime numbers and try to find common prime numbers between those two prime factorizations. We have found here two methods. First one, writing all the multiples of two numbers and find LCM, and the next method is finding LCM by prime factorization method. What is the LCM of any two prime numbers? If those are composite numbers, try to write prime factorization. If those are prime numbers, then we need to multiply directly two prime numbers to get their LCM. Directly we have another method to find LCM here, that is division method. Let us discuss the division method here to find LCM. Find the LCM of 24 and 90 in division method. Okay, by writing separately before this example we found prime factorization. Without writing prime factorization, directly we can divide these two numbers by prime numbers, we get LCM directly. Now take first prime number 2 here, as these two are even numbers. Now divide this 24 by 2, we get 12 here, and divide this 90 by 2, we get here 45. So we have divided these two numbers by first prime number 2, as these two are even numbers. Now divide these two numbers by 2 here. First number is 12 here. Once if it is divided by 2, then we should write the product here, answer here. Coefficient is 6 here. 45 is odd number. We cannot divide this by 2. Hence we need to write as it is. Now take another number which divides these two numbers. So we need to check by prime numbers only. Writing prime factorization at a time. If it is not divisible by that number, we need to write the number as it is. Now we have taken 3 here. 3 divides these both numbers. 3 how many times is 6 here? Yeah. 3 how many times is 45 here? Yeah. Write these two answers here. Divide the answer separately in your rough part and write the coefficients here. 3 2 times is 6 and 3 15 times is 45. Now 2 and 15. In the same manner, we are continually dividing these numbers by prime numbers only. 2 divides here 2, but 15 is not divisible by 2. Hence we should copy 15 as it is. Now 15 should be divided by 3 like this. Hence 3 into 5 is 15. Now write all these prime numbers to get the LCM directly. First prime number is 2, second prime number is 2, third prime number is 3, and next one is 2, and next one is 3, and next one is 5. Hence we will get the answer here, 360. So while multiplying, we need to find any tens are there. then it becomes easy to get the product here. Now the LCM in division method is 360. Of 24 and 90 here 360. This is called division method. Let us look into another example. Okay, division of 48, 52 and 72. Now try to write all these numbers and divide by prime numbers. How I am dividing, you observe and note it down in your notebook. All these are even numbers. 48 half is 24, half of 56 is 28, half of 72 36, and hence now divide again by 2. Half of 24 is 12, half of 28 is 14, half of 36 is 18. In this manner, divide by prime numbers. If it is not divisible, then copy the number as it is. Here again we divided by 2 here. Next I am taking here 2 again, 3 times. 7 and 9 are not divisible by 2, hence I copied as it is. Now 3, 7, 9. Now divide by 3, and these are the end products. Once if you get the prime numbers, you can stop the dividing by prime numbers, hence the prime factorization combinedly is finished. This is called short division method to find the LCM of any 2 or any 3 numbers. Now copy all these numbers to get the LCM. 2 into 2 into 2 into 2 into 3 into 7 into 3 here. Now multiply in your notebook all these numbers. We are not getting any tens here, so multiply continuously. So we get the answer is 1008. Check with your multiplication whether this is correct or not. Otherwise discuss with your friends and teachers. With the help of this one, we studied 3 methods. One is writing the list of multiples and prime factorization method and division method. First one, find LCM of 15 and 18 in prime factorization method. Note it down in your notebook. Copy this question in your notebook and get the answer. Find LCM of 26, 14 and 91 in division method, as we have studied just now. In real life situation also, we can find the LCM by taking the examples like this. Find the smallest number which when added to 5 is exactly divisible by 12, 14 and 18. To find the answer, we need to find LCM of these 3 numbers. Get the LCM of these 3 numbers and add 5, we get the number which is divisible by 12, 14 and 18 exactly. Students, try to write 2-3 numbers and get the multiples of those numbers and find common multiples and get LCM. Create new questions on multiples and give it to your friends and discuss with your teacher. Create some questions based on LCM. Take examples from your textbook and solve those and discuss with your friends and teachers. In this manner, you need to write creating new questions and some activities and discuss the LCM in your daily life. Thank you for watching this Bridge Course digital class. Thank you one and all.